All right, let's try to solve this problem on mensuration, focusing primarily on cube and cuboid. So let's try to see what's going on here and how can we get it going. Okay. So the question over here is find the length of the longest pole that can be placed in a room 12 meters long, 9 meters broad, and 8 meters high. That's your question. The first and foremost thing that you do before solving the problem is once you've identified that this is a mensuration problem, you just read each word of the question carefully to pick up the hints and kind of formulate the strategy and identify what question is all about in your head. Okay, what are the different things we have? We know that they are not talking about cube or cuboid directly. There is no mention of that, so we don't know what is the shape, but it's given that it's a room. And when you talk about a room, along with that they are given three dimensions: length, breadth, and height. And then you're talking about a room. That means in your head you should imagine that any room technically is a cuboid because it's of this shape. If you see here, it's of this shape, right? So although they are not mentioned cuboid, one of these two clues is sufficient for you to conclude that this is a cuboid problem. One is the room, and two, the three dimensions: length, breadth, and height. Okay, that's the first thing. Okay, the second thing is it's asking about the length of the longest pole. If you remember when I was trying to explain the diagonal of a cuboid problem, I told you that this might come. They're talking about the length of the longest pole. So immediately what you should do is once you've identified this is a cuboid problem, and once you draw a visual in your head, like I mentioned here, imagine the visual and draw it in a rough sketch. You don't have to take you just take a pencil and doodle it like this. Okay. And what they're asking is the longest diagonal. We know that it is going to have two diagonals. This is the shorter diagonal, this is the shorter one, and then this is the longest one. Okay, so they're asking what is the longest length of the pole that can be placed inside. So obviously, if you are going to place a pole inside this box, which is in cuboid shape, the longest length is going to be this is the longest length that you can place. You cannot place anything longer than this because this extends from one vertex of one side of the bottom of the cuboid all the way to the extremely diagonally opposite vertex on the top side of the cuboid. That's the longest length that you can have. So you can assume or you can conclude that the longest length or the length of the longest pole is nothing but the length of the longest diagonal. That means we have to calculate this. And once you identified that, you exactly know what you need to do. And you know that for the cuboid, the length of the longest diagonal is nothing but square root of all the three dimensions, the square of all the three dimensions, L square plus B square plus H square, because we applied the Pythagoras theorem. In case you want a refresher, you can check out the cuboid video on diagonal of a cuboid. Okay. Once you get that, the calculation is very simple. The length is given, the breadth is given, and the height is given. These are the given parameters. You just apply the values. And simply substitute in this particular formula. That will give you the length of the longest pole is equal to the length of the longest diagonal, and you substitute the values. You are going to get square root of 289, and once you compute the square root of 289, you're going to get the unit as 17. And as always, we need to put some units to that. The given problem already has a unit in meters. If you see here, it's already given in meters, and you're going to carry forward the same dimension or the same unit of measurement over here, and that's the reason I put this in red. If no unit is given, then you can write it as 17 units or whatever that is. Okay, but if the unit is given, then you just put the same unit that is given in the question. So the answer of this question is 17 units, and that's your final answer, and that's how you secure marks. So that's a quick wrap up on this topic. We'll move on to the next topic in the next episode.